guy's good. I like his videos. I hate the crappy covers, but I do like his videos. So, flat earthers keep asking for proofs. Give me your best proof. Funnily enough, they're not the first people to ask me for a proof. Years ago, a neighbour came round and asked for proof to help her son with his maths homework, because he'd been asked for a proof. You may have seen the sun in the Olympics in London. The proof he was asked to give was that a square is the rectangle of fixed perimeter with the greatest area. Let me just cast shadows all over the place while I make sure this is actually on the screen. Yes, it is. That's good. So we start with a rectangle. Length, width, area. The area is length times the width. Try it yourself with graph paper if you don't believe me. And the perimeter is twice the length plus twice the width. 2 lengths, 2 widths, twice, bracket, length plus width, bracket. Length plus width there, length plus width there. Try it yourself with graph paper if you don't believe me. What it wants is a maximum. Now you could plot a graph, and you do in fact get a graph something like that, and just say, look, that's the maximum there. But it wants a mathematical proof, not a graph with an arrow on it. However, we can use this graph to illustrate the point that at a maximum value, if this is distance downrange and this is height of tennis ball or cannonball, or if this is time since the shot was fired and height of cannonball, this is the distance at which, or the time at which, the cannonball is at its greatest height, and is therefore not moving up or down. The gradient of the cannonball's travel is 0. If this is a graph of the area of the rectangle against its length, the maximum is the point at which the area is at a maximum and is not changing. Just momentarily not changing. Rearranging this a little, the length is half the perimeter minus the width. Split it across there, get half, or there if you prefer, half the perimeter, subtract the width, what's left is the length. Or the width is half the perimeter minus the length. Either way works, you can use either. The area can therefore be defined, length times width, length times half the perimeter minus the length, that, which expands to half the perimeter minus the square of length, or to put the square first, minus 1 L to the 2 plus a half p L to the 1. To find the gradient, you differentiate dA by dL, the rate of change of area with respect to length, is this power here, plus 2, multiplied by this number here, minus 1, gives you minus 2, L to the power of this minus 1. 2 minus 1 is 1, so minus 2L to the 1, which is just minus 2L, plus this power here, 1, multiplied by this thing here, p over 2, which is p over 2, times L to the power of this minus 1. That minus 1 is 0, L to the 0 is 1, so p over 2 L to the 0 is just p over 2, or half p. Minus 2L plus a half p. Where it's at a maximum, that must be 0. Minus 2L plus a half p is 0. Add 2L to each side, you get half p is 2L. Halve each side, you get a quarter p equals L. And that's a quarter of the perimeter. I'm not talking about anybody taking a miniature Riley here. If we then substitute that into this, we get that the width is a half the perimeter minus a quarter of the perimeter, which is of course a quarter of the perimeter, which we've already established is the length. Width equals length for a rectangle pretty much is the definition of square. That's what a square is. So we know that is the point at which the gradient of area with respect to length is 0. But that is also true at a minimum. This is a graph of something else. X squared, sorry, open bracket x minus 5 squared plus 6. It helps you put the close bracket in. CS will make each day a quest to find a missing close paren. Open bracket x minus 5 close bracket squared plus 6. Might look something like that. You also have dA by dL equals 0, or dy by dx equals 0 here, at a minimum. The difference between the maximum and the minimum is that here the gradient is going from positive to negative. It is decreasing. Here it is going from negative to positive. It is increasing. So the rate of change of the gradient with respect to L, the rate of change of the rate of change of A with respect to L with respect to L, is negative here, positive here. It's easier to just say d2A by d2L. It's so much easier. And to get that, we take that and do the same thing as we did to get from there to there. Minus 2L to the 1 becomes minus 2 times plus 1 is minus 2. L to the 1 minus 1 is 0. Minus 2L to the 0, also known as minus 2. Plus a half p L to the 0 becomes plus half p times 0 L to the minus 1. Half p times 0 is of course 0p over 2, or 0 L to the minus 1 1 over L. So it's 0p over 2L, which is 0. So all of that is just minus 2. A negative number, therefore the gradient is decreasing, therefore it's a maximum. The fact that you only have two terms, you don't have a cubed or a to the 4 or to the 5 or anywhere, means you're going to get that shape. You could, if you wanted to, get more elegant about it and say all kinds of complicated things to prove that it's the only one, but there is only one solution possible here. It's not a quadratic. So if there's only the one solution, it's the only place where the gradient is 0. It is the maximum, or minimum, but in this case we've established it's a maximum. Or you could just plot the graph, which does in fact look like that. Type in y equals x, open bracket, any number, minus x, close bracket. P is a constant, so it doesn't really matter. All it does here is scale it. What value you put for p just scales this graph up. It doesn't change its shape. And a Google search bar, you type in that formula using y and x, press enter, you will get that graph. Don't worry about the negative parts. Negative area is not a thing. So there you go. Flat Earthers wanted a proof. There's a proof. On the side, literally on the side, a little bit of fun. Sine wave, if you look at the gradient of it, it is minus 1 there, 0 there, plus 1 there, 0 there, minus 1 there, 0 there, plus 1 there, 0 there. These are right angles. So that is one full circle. That is two full circles. Also full cycle of the sine wave. No big surprise. If you plot that gradient, you get this. From 0 to minus 1 to 0 to plus 1 to 0 to minus 1. And that line is the cosine. So d sine A by dA is cos A. And if you do it again, you get the exact same curve shifted one space farther left, which is the sine wave reflected about the a-axis. So d cos A by dA is negative sine A. Fun piece of trivia. That I don't think I've ever needed. But whatever, they wanted a proof, they got a proof. There it is.